Welcome to Moments with Atmospheric Ripper, where we explore the cutting edge atmospheric water harvesting technologies. Today, we are pleased to have Professor Jeremy Cho from UNLV, University Nevada, Las Vegas, a leader in the field of atmospheric water harvesting, and Rick from WAVR Technology Company. Thank you for joining us, guys.
Thank you.
Thank you for having us.
Perfect. Jeremy, to kick things off, could you share your thoughts on where atmospheric water harvesting technology stands today, and where do you see it heading in the next 5 years?
Yeah, I think it's a great question, and I assume you mean like sort of AWH technology in general, right? Not just our technology. Yeah, I mean, I think it's still very much in its infancy, right? And I think we're still very much at a point where we have to still communicate to the public that this is possible, right? It still seems like science fiction, I think, to a lot of people. And the devices and the technologies that we've seen so far, they're usually very small, right? Or they're very large with very small outputs, right? And I don't think we've really seen anything groundbreaking in terms of like small size, large output, low cost, right? Something that an everyday person can go out and just buy and install yet, right? So it seems very specialized, but I think we're gonna start to see more inroads being made in the next 5 years. As we all get better at this, right? I think we're gonna specifically be able to produce more water at smaller sizes, simpler devices, and at lower cost. That's how I kind of see that, in the next 5 years.
Perfect.
I mean, I want to jump in if I can.
Yes, of course.
Thank you so much for spending some time talking to us about what we're trying to do in atmospheric water harvesting. So Waver is the startup company that has been licensed the technology that embodies all of this great research that Jeremy and his team have done. And we see ourselves sitting in a reality where over the next 10 years, demand for fresh water globally will outstrip supply by 40%. So we're using credible third-party sources for these kinds of trajectories and predictions. And so we can continue to apply conservation efforts for water. But in addition to that, we are going to need to come up with new sources of water in order for economic development to thrive, in order for communities to be healthy and stable. And so we believe atmospheric water harvesting has a very important place in that picture. And when you think about 5 years out from now, we are hopeful as a company, Waver, that we are shipping units and we are enabling customers to source thousands and thousands of gallons at their locations from the atmosphere that otherwise would have been from the tap. And in doing so, they will be able to fully execute on their business plans or thrive as communities. So it's a vision that right now seems to be completely unformed and unrealized, but over the next 5 years, we expect it to gel.
No. This question is from both of you. It's for both of you. Can you elaborate more on what specific advancement you foresee that might transform atmospheric water harvesting technology within that time frame?
Yeah, I mean, I think the biggest needs right now for atmospheric water harvesting is low yield, right? Like the current problems are low yield, large device size, complexity, high cost, and energy consumption, right? These things require oftentimes on the order of kilowatt hours per liter of water generated. and also flexibility, right? Where can you put this thing? Where can it operate, right? What types of environments? Does it work in the driest environments? Does it work, what can you say, take that same system into a very humid environment? So, how small can it be? Can you put it in a backpack, or does this have to be a permanent installation? I think we're going to see a lot of different, from our company, but also from other companies and other researchers. We're going to see a lot of different advancements in those respects, I think.
Rick, do you have additional comment?
Yeah, I think Jeremy was getting to a very important point there when he talked about flexibility. We have a reality where the driest conditions and the most extreme need for additional water is in the places where it's hardest to harvest water from the atmosphere. So most of the old school technologies will just simply not function effectively in the kinds of humidities that are reality in the arid Southwest, for example. So it's really crucial that we, along with any other technologies and solutions in atmospheric water harvesting, have an operational effectiveness in humidity, say down to 10%. And so that's part of the niche that we expect to fill, and it's a significant advancement in the technology overall that we represent. I'll say one other thing too. I don't think it's the best use of all of our time for us to say we're the only show in town. We actually want an industry to be built around this. We want every company in every community thinking about atmospheric water harvesting as a viable option. And so we want it to be part of the standard of doing business sustainably. And we want to be one of the companies contributing as part of the solution for that. But it's a good thing when there are multiple solution providers that make up a market make up a viable market.
Perfect. Okay, let's jump into your recent published paper about highly yield atmospheric water capture via bio-inspired material segregation. May you please explain more about it? What was the inspiration behind using hydrogel membrane in your atmospheric water harvesting system? And what makes it more effective in comparison with other systems?
Yeah, great question, and it's something I've been thinking about a lot. I mean, I think about atmospheric water harvesting for some time, before we actually formally started this project, and what I noticed was, the typical approach for at least for atmospheric water harvesting is you have some kind of sorbent, usually solid, right? And you load it up with water, right? You expose it to an ambient air environment, and then you subsequently release it, right? And that involves a cycling, right? And so it means that this sorbent is either cycling or releasing, and that kind of limits that time window for you to be capturing water. And so we felt that like a more continuous flow through approach, would just be more effective overall. And so, with a lot of complex problems, a lot of times the answer is right in front of us in nature. And so we looked for bio-inspiration, and we saw that tree frogs will absorb water and hydrate themselves by kind of going in and out of their tree hollows. There was a study on Australian tree frogs. We also know that air plants can hydrate themselves in humid environments. In all of those cases, the similarity is you have some sort of thin membrane, which could be the skin or the cuticle of that organism, and water vapor transports across it and into the organism itself, right, into the extracellular matrix. So we try to replicate that architecture, and we realize, okay, let's look at that skin. Let's replace that with a hydrogel membrane that we can make, and that's something we've been doing in the lab. And then the interior of the organism, which is kind of a salty environment, let's just replace that with something really, really salty, right? And so we actually found that lithium-based salts are some of the most powerful desiccants out there. And so if we use a strong salty solution, then that can drive water capture all the way down to like 10% humidity. So with that combination of a hydrogel membrane coupled with a liquid desiccant system, it kind of, it gives us high performing liquid desiccant based system, but has the benefits of a solid state system, right? Because you don't have to, you know, think about how you flow that liquid and exposing that liquid desiccant to the raw elements in the air, right? And so that hydrogel membrane provides that also benefit of protection, right? It can protect, it can block out contaminants that might be in the air.
Perfect. Rick, would you like to add more comment about it, especially with increasing global water shortage? How do you envision the development of your atmospheric water harvesting technology in practical scenario, especially in arid and semi-arid areas?
We have the virtues of this really elegant, nature-based inspired system, and we plan to deliver to the market units at various scale levels. So we're envisioning, and I'll put it in gallons per day because I'm kind of on the layperson side of things. We're envisioning 100-gallon per day units, 1,000-gallon per day units, and maybe jumbo units that are more on the order of 10,000 gallons per day. Eventually, we envision downscaling this to a personal pack, like Jeremy referenced, or something that's mountable on a vehicle. You can imagine an RV application where this would be great, or military applications where this would be great. And so there are those scenarios as well. And we are developing the system that Jeremy described on a modular basis. So I have to watch my hands here because it's picking up gestures. The modular flexibility that we have will allow us to work with a customer that has a 5,000-gallon daily demand by putting in 5 units ganged together. And so that's our general approach to the market. The kinds of applications range from irrigation to in-home distilled water for medical applications, to beverage companies that have use for this in process or food making or beverage making, even to things like chip making, which can be very water intensive. So we have dialogue across a wide spectrum of commercial use cases. We've been in touch with a leading global nonprofit organization that is involved in emergency response and stabilizing communities that are affected by emergencies. Water, fresh potable water being one of those key resources they need. So lots of applications. For us, the units probably won't change that much in how they operate. There will just be a different scale level and a different mixing and matching of the modular units to satisfy the daily demand of water per customer.
Perfect. I hope both you can answer this question. Looking at the environmental and economic impacts, what makes your atmospheric water harvesting technology a sustainable solution to address water shortage?
Yeah, I mean, I think water stress, right, is a serious issue, and it's a massive issue, meaning it's a massive scale, right? And I think when we look at new solutions, like as Rich said, we have to continue doing what we're doing already and do it better. I mean, that means we need to be better at conserving water. We need to be better at reclaiming water and recycling water. But in addition to that, we have to figure out how to use new sources of water, right? And new sources of water is not going to be, we can't just create a new lake or a new river. We have to look at the atmosphere around us, and there's a lot of water out there, right? And I think if we're going to look at new sources, they have to be at pretty large scales to make an impact, right? So I think my opinion is that applications that look at perhaps only small drinking water usages, while there's an important market there, in terms of larger environmental and sustainable impact, it's not really going to make much of a dent, right? Because a lot of our water is not just drinking water. So we're looking at total consumption of water all the worst types of consumption water, which is like evaporative, right? Or lost to the ground. So irrigation, cooling towers, things of that sort. That I think should really be, the most expensive in terms of the impact of our environment. And we want to make sure that we can offset that, right? And so we think that as long as, if we really push the yield, as in being able to produce the most amount of water in this, the smallest, cheapest package, and being able to do it as energy efficiently as possible, is really going to give us the economic indication, right? That we can reach a certain amount of price per gallon, right? That I think our customers will start to understand that this is the way forward, right? And so that's
and Jeremy,
yep.
Yeah, Jeremy, you just mentioned price per gallon. I'm just jumping in to say, sustainability can be defined strictly in environmental terms, but it can also be defined as infrastructure terms or business terms. And
Exactly.
sustainability needs to equate to affordability, like Jeremy is referencing, in order for it to be truly sustainable. So that's crucial. I want to add, Jeremy, if I could, just a couple aspects of sustainability. First of all, the inherently the design that Germany has created is for the most part solid state. There really aren't a lot of moving parts associated with this. And the salty solution inside, for example, that is all in a closed loop. So it's not like we're going to have to be replenishing a lot of chemical material in order to have this function. It should function for a very long time, very efficiently, without a lot of maintenance or additional material to be added to the process. So that's a nice sustainable attribute. And the other thing is the way Jeremy and team have designed this, we can also use sustainable energy inputs to drive the whole process. So if it's an industrial site and they have a lot of waste heat, we can utilize that to yield our pure water out of the salt. Alternatively, we can use solar or other renewable energy to also drive that process. So we're trying to think of it in a very kind of macro, holistic kind of way in terms of how we define sustainability.
A couple more points I want to add on to that is, the fact that like sustainability really was the goal from the outset of this project, right? So the whole design of this was for us to achieve sustainability. And what that for us, that meant flexibility, right? Being able to use a variety of energy sources, whether it just be, from anything from just straight up grid power, all the way to utilizing solar or waste heat, right? The architecture of our approach, right, allows us to separate the different components, right? And when you can separate, like where the capture occurs, where the storage occurs, where the release occurs, that means you can separately optimize each one of those steps. And that kind of relates to the economic principle of specialization. When you have separately optimized components, you can get overall higher performance. So that was our kind of design philosophy from the very beginning. And we felt that really was necessary, that you need that flexibility to achieve ultimate sustainability.
Perfect. Thank you guys for sharing your insight and expertise on the field of atmospheric water harvesting. It's so clear that your work has great potential to make a significant impact on water security worldwide. If you have more comments or more points, we would be happy to listen it. If not, we can stop our podcast here.
This is great, and thank you so much for this time. We love talking about this space. We couldn't be more passionate about it, and we appreciate the platform.
My pleasure. Okay, to our listener, thank you for tuning into Moments with Atmospheric Vapor. We hope today's discussion has provided you with a deeper understanding of the potential and progress in atmospheric water harvesting technology. Join us next time as we continue to explore innovative solutions to our world's water challenging. Thank you.